Welcome back. Today I'm going to do another video on stoichiometry. This one dealing with if you're given in a problem the mass of the reactant and you are asked to figure out the mass of the product, you can do that using the principles that we've already discussed. So in the problem that we're given here, we're given the amount of barium, and we're supposed to assume that that's completely consumed and that produces a certain amount of barium oxide. Again, the oxygen is considered in excess. So let's just write down a little the given information under the individual components of the reaction. So we have barium is 11.176 grams. We know that this oxygen is in excess, so that's excess. And we want to figure out this. Now, I'll say why in a few minutes, but for us to convert to mass, we're going to have to use the molecular weight. So here this row will be the molecular weight. Barium is 137.327, and barium oxide is 153.3. Next, we have to remember what our toolbox allows us to do. So let's define what our toolbox is by saying, okay, toolbox are the relationships that we're going to use. We know that the number of moles of a compound A, let's say, is going to be equal to the mass of A divided by the molecular weight of that substance. So that's one of our tools. And the other one is the one that was discussed in the earlier videos, and that is that the number of moles, so this deals next with the reaction. So if we have, let's say, product C and reactant A, they will be given by the ratio of the stoichiometric coefficients for the balanced reaction. So if C, lowercase c, and lowercase a are the stoichiometric coefficients, then the ratio, when the reaction has taken place, the ratio of n sub c over n sub a will equal the ratio of those stoichiometric coefficients. So that's our two relationships that we're going to use. We then substitute in place of, so for this reaction, let's just write it out longhand for this reaction. I'm going to put a box around these things in our toolbox. And go back to this, and then let's write out this in terms of our actual reaction. So we would have that the number of moles of BaO over the number of moles of Ba equals, and then we look up at the balanced reaction and we see that there are 2 moles of BaO. Then we get for every 2 moles of Ba. So the ratio of this coefficient will of course be just 1. Now we're not given moles, we're given mass, so we have to replace the number of moles in here with mass. So let's do that. So if we want the mass of BaO divided by, from our toolbox, divided by the molecular weight of that compound, that quantity divided by the similar thing for Ba, so the mass of Ba divided by its molecular weight, that's going to be equal to, for this reaction, that's going to be equal to 1 mole of BaO per 1 mole of Ba. Now we can rearrange the reaction so that we have just the unknown on one side and everything else on the other side. So the unknown is the mass of BaO, and we're going to set that equal to, so we're going to bring over first off the mass of Ba, and then we're going to bring over the molecular weights. So the molecular weight of BaO would be here, and the molecular weight of Ba here, and that's basically all we have to do to set up our equation for final analysis. So we now put in our quantities that are given. The only thing that's given in this is, as far as reactant, is 11.176 grams of Ba, and the molecular weight of BaO goes on top, and we said up here that that's 153 grams of BaO per mole of that. And then we divide that by the atomic mass or molecular mass of Ba, which is given as 137.327. Whoops, sorry, I'm off scale. There we go. Grams of Ba per mole of Ba. Now, of course, the units that we had left on up here in the original equation says 1 mole of BaO per 1 mole of Ba. So we can start canceling things that are possible. So here we go with the Ba, and the mass of Ba gets canceled. The moles of BaO get canceled. So our unit that we're left with, sorry, I'm off scale again, I apologize. So what we're left with is the units for BaO, grams of BaO, which of course is what we were after. So you carry out the arithmetic, and you can see that the answer is 11.176 times 153 divided by 137. So a little more than 11. It actually turns out to be 12.47 grams of BaO. Now, there might be other ways you can do that, but that's one fairly straightforward way of figuring it out. I think if you were in my class, you saw me do it in a slightly different way that works also. But anyway, hope that helps you out. Have a good day.